Welcome back to Computer Science 163 at the University of Wisconsin-Eau Claire. This is mini lecture number 7, where we'll talk about vectors. I really encourage you to watch this video, this YouTube video I've included here. It's by someone who is much more skilled than I, who goes through some examples with vectors. Before we begin, let's review some questions. I encourage you, as always, to pause here and check yourself, to quiz yourself, as these are some of the questions that you might see, for example, on a quiz or a test in the future. So pause. Arrays are wonderful because they let you store multiple pieces of data in the same variable. In spite of that, they can also have some limitations. So let's illustrate that with this example code. Take a second to pause this and see if you can figure out what's wrong with these 4 lines of code here. In a moment, we'll resume. Okay, so these limitations really only apply to statically allocated arrays, the kind that we've talked about, where you have to give it a special size, or a certain size. There's another kind called dynamically allocated arrays that we won't talk about now. We can talk about that more when we talk about pointers. And this doesn't apply to them. But for static arrays, like we've talked about, they have these limitations. The first is that arrays can't be resized. So in the example up here, we're not really resizing the array. We're just declaring it to be of, some length size. We're never changing that size. So that doesn't apply. That's not the problem here. But 2, the size of the array has to be a compile time constant. So when I declare an array of integers called user numbers, then in brackets I have to have a size of I could either put a number like 20 or 200, or what I could do is I could declare a constant variable like const in length equals 400 above that, and then I could then say int user numbers length, where length is a compile time constant. Basically, the compiler has to know how much memory to reserve for this array, and it has to know that when this code is compiling, not when it's run. This code here is asking the user to tell it how long this array is going to be. Therefore, the computer doesn't know how much room to store for it until the program actually runs. So this won't work. Vectors, on the other hand, are awesome. It's a new variable type. It's a class variable type. We'll talk about that in a moment. That makes arrays much, much easier to use. They're similar, but they're different. Let's look at the similarities. Vectors can store multiple objects of the same type, just like arrays. Vectors elements are also contiguous in memory. They're all next to each other. Vectors, like arrays, use a special kind of array under the hood. And again, vectors are using dynamically allocated arrays, which can be resized. That's a bit fancier. It involves a bit of extra work, but whoever wrote the code for vectors and how to use them, they figured that out. We don't need to. Vectors also use square bracket notation to access elements, just like arrays. So that's pretty awesome. Vectors and arrays also have some differences, which we'll talk about here. Arrays are built into C and C++, and we know how to use them now. But arrays come from a class, which means that they can contain extra data as well. We'll talk more about what a class is and what it means to be a class on one slide later in this lecture, but then also in more detail towards the end of the semester. Arrays have a fixed size, whereas vectors are resizable. Yay! That's good for vectors. Vectors keep track of their size, so remember how we had to pass an array into a function with its size. Otherwise, we wouldn't know how big the array was. When you pass a vector into a function, you can ask the vector, what is your size? And the vector will tell you, which is cool. So this means we don't have to pass in its size to a function. An array can't be the return value of a function, but a vector can. So that's also cool. Array elements, if you're going to copy from one array to another, you have to copy each element of the array one by one by one by one. Vectors, on the other hand, you can copy all of the values at once using the equals operator. Now under the hood, as we'll see in a few slides, it's also doing the copying for us, but this allows us to use some simpler notation to make our code look a lot cleaner. Also, arrays are a bit faster than vectors, and they use less memory. So basically, vectors are they're using a little bit more memory, and they're a little bit more complex to use. However, ultimately, I find them to be much easier to use than arrays, and overall, they're definitely worth it. And I would use an array over an array, or I would use a vector over an array almost any day. If you want more information, a good link here. What does it mean for a vector to be a class object, though? A class object is a new kind of variable type. So let's think about the variable types that we know. There's primitive data types like int, bool, double, char, and these represent only a single value. So an integer can contain, it's just got enough space for an integer, 42, double, 3.14159, boolean, true or false. They can only have one value, but a class is basically a new kind of variable that can contain other variables as well. Some examples of this include the vector class. So it has an array of values under the hood, but it also keeps track of its size. The string class is similar. The string has a bunch of different characters in it, and then it also keeps track of its own size as well. OStream, blast from the past. An OStream or output stream is an example of that would be the cout output stream. So whenever we use an output stream, we're writing something to that stream, and it's going to eventually, if it's cout, if we write something to cout, it's going to eventually go to the screen. So it takes a bunch of extra variables under the hood to make that happen, and all of those variables are hidden in the OStream class, so we don't need to worry about them. So classes are what we call compound data types. They can contain additional variables under the hood, and examples are the array and length of strings. Additionally, besides being compound data types, classes allow you to define functions that act on variables of that class. So you can have a function that returns the length of a string. You can have a function that returns the length of an array. You can have a function that says, is this string all capitals or not? And so this makes class objects very, very useful to use. Again, this is all we'll talk about classes here. We'll talk about it in more detail at the end of the semester. How do we declare or initialize, and ultimately, how do we use a vector? Let's compare with an array to see how that's done. So if we want to declare an array of 5 unsigned integers, we can do it using that line of code at the top. Unsigned is the type, myArray is the variable name, and bracket 5 end bracket is saying that we want an array of 5 of them. So it'll have an array of 5 unsigned integers. If we want to declare a vector, we use the line below, vector bracket int bracket my vector. Now that's going to not say that, oh, there's 5 elements. It's just going to start off at size 0. We'll add stuff to it later. But what's going on with that? Now a vector is a special kind of object. It's called a template object, which means that it can hold any kind of other kind of object that you want to give it. And in this case, we're giving it an integer. So what's its actual type? We need to specify what kind of vector it is. Is it a vector of doubles? Is it a vector of booleans? Is it a vector of strings? All of those are possible. Is it a vector of vectors? That's possible too. So we need to tell it that it's going to be a vector of integers. That's going to, under the hood, tell it that we want to have an array of integers under the hood somewhere. So the type of my vector is vector bracket int bracket. Now, how do we initialize that vector? Well, you can initialize an array a couple different ways. You can initialize each element of the array separately, manually, maybe on different lines, or you could put it in a for loop, and that's what I've done here. So my array, I will use the bracket notation to set each index of that array equal to the value of that index. So 0, 1, 2, 3, 4 for each of the 5 elements of the array. For the vector, I can pretty much do the same thing, except instead of, I could use the bracket notation if that vector is already size 5, but remember it starts at size 0. So instead what I'm going to do is I'm going to add the elements to that vector. It starts at size 0, and every time that I add to that using this pushback function, I'm going to push back the value I onto the end of the vector. Let's see what this looks like. So assume that I've got this vector and it has the elements 0, 1, 2, 3, 4 for 5 elements. Here's what it looks like. I've got the front of my vector on the left corresponding to the first element in that vector. The back of the vector is the last element in that vector. So here I see that my vector size is 5. And you know what? It looks like an array because under the hood, again, it uses a special kind of array. But remember, it also keeps track of how big it is. Let's suppose now that I add the number 99 to the back. So here I am using the pushback function and pushing the value 99 onto the back of my vector. How do you suppose that would change this diagram? Pause here, take a sec to think, let's move on. If I push 99 onto the back of this array, then I basically add this new element to the end of the array. And 99 now becomes the new back of the array because now that's the last element. Now the indices are, instead of 0, 1, 2, 3, 4, now I have 0, 1, 2, 3, 4, 5, and my vector size is 6. Cool. There's also a push front function. And as you might expect, that's going to add a value onto the front of this array. So take a sec to think how the size, the indices, and this diagram would change once I do the push front 32 function. If I push 32 to the front of the array, I add another box to the front, I move the front designation to the 32 because that's now the front of the array, and then notice what happened to all of the indices. The part of the array, the element of the array with 0 used to be at index 0. Now it's at index 1 because it's now the second element of the array instead of the first element in the array. Also, the vector size is now 7 instead of 6. One thing you may have noticed that's a little funny about how we use vectors is that you use a period after the vector's name, after the variable name, to call the function on that vector. And that's because a vector is a class object, and that's how we call functions on class objects, usually. So if we want to use the push front method onto a vector called myVector, we use the dot symbol. That means that push front is an operation, and it's like an order, and we're ordering myVector to do this function to itself. So we're telling the vector to push a value to its front, in this case 47. And if we could do push back, and that's telling myVector to push a value onto its back. And then we add another one, we can add that value onto its back. There are some other functions too that I'd like to introduce. One is size. If you want to know how big the vector is, you can ask it. So myVector.size tells myVector to return its size. And size is a function that returns the size. Clear is another function, a vector function, and if you do myVector.clear, it will remove all elements from my vector. You're telling my vector, empty yourself, clear yourself of all your elements. Another useful one is resize. There's two different ways that you can call it. One is resize 20, and so if my vector has a size that's smaller than 20, then it will suddenly make it grow bigger to be up to 20. If it's bigger than 20, if it has, say, 50 elements, it's going to shrink and only contain the first 20 elements. If you call it with resize 20, 100, then if your array is, say, size 50, or say if your vector is size 50, it's going to shrink it down to size 20 and ignore the 100. But if your array is size 5 and you say resize up to 20, then it's going to fill in the last 15 values with the value 100. Cool. Another really useful feature for vectors is a special function that doesn't even really look like a function, and that's okay. It's the assignment operator, or the equality operator. You can actually, the vector class rewrites what it means to be equals for the vector object. And that's complicated too, we'll talk about it when we talk about classes. But suffice to say that you can set one vector equal to another vector. And in this case, we're replacing or copying all of the values of my vector with the values of those from the other vector. So now my vector will have the same size as other vector, my vector will have all the same array elements as other vector. Now, how do we get or set values of a vector? If we want to get the value of an array, we use the bracket notation. If we want to set the value of an array, use the bracket notation. So the same thing is true here with my vector. We can get or set the very first element of an array or vector using this bracket notation with index 0. Now the vector class has an additional function that will return the value. You can't use this to set the value, but you could get it to return the value of that very first element. And that is my vector.front. Now there's a similar one for the back. If you want to get the very last element of a vector, you can just ask it, my vector.back, what is the back value? You could also do it using the array notation right above with the brackets. My vector and then my vector.size -1. That's the same thing as you would do for an array element if you were trying to get the value of that array element at the last array element. Now if you, the very first line there, my vector and then brackets my vector.size -1, you could say all that equals whatever value. But my vector.back, you couldn't say my vector.back equals 3. The back function, like the front function, is only returning the value. It doesn't let you set the value. But how do we do this at anywhere in between the front and the back? Because that's the important thing. With arrays, you use the bracket notation, as you've seen, and for vectors, you can do the same thing. This works for getting the value or setting the value. The vector class also gives you another way to get the value at a certain index. If you'd rather use the at function, you can do that, and it acts just like the bracket notation, except it only returns the value. It doesn't let you set the value. In summary, the vector class has tons of features that you can use, and I've only scratched the surface. The vector class is my favorite C++ class because it's just so useful and it really improves on arrays in a lot of ways. The best reference for figuring out how to use the vector class is this one right here. C++.com in particular is the best C++ reference site in terms of telling you how to use different features and different classes and different functions in C++. And if you check out its reference for the vector class, it doesn't disappoint. It has example code for you to check out. It tells you exactly what's going on. Some things might be a little bit beyond our scope. That's okay, you can ignore that. But I think most of the stuff you'll be able to understand, hopefully. Another thing that's cool about vectors is that because they can hold any other object, you can create a vector of vectors. You can create a vector that holds another vector of doubles. And so if you do that, you can use that to represent a 2D array, or a 3D array, or a 4D array, or so on. You could have a vector, a vector, a vector of vectors of doubles, which is kind of cool. It gets confusing, but it's cool. Some features that the vector class has, like iterators, we haven't talked about, we won't talk about, they can be really useful, but they're beyond the scope of this course, so I just won't talk about them here. If you're interested, hit me up. I'd love to talk about them. So here are some review questions. I'd encourage you to pause here, take a sec to write down in your notes, see if you can answer these questions, and then check yourself, go back and see if you got these right. And finally, a practice problem. See if you can do this, challenge yourself, help yourself grow, and it'll give you some good practice actually writing C++ code and seeing if you can compile it. This is a fundamental part of the course, so I really encourage you to try these practice problems. First, ask the user how many doubles they want to store in a vector. This is just like that example problem we saw earlier in this mini lecture. Then, initialize an empty vector of doubles, and then in a loop, prompt the user to enter a number, get the number from the user, and then add that number to the vector. So for instance, I might say, hey user, how many siblings do you have? And then they'd be like, 3. And then I'd be like, okay, let's go in a loop, 3 times. And I'll say, what is the age of your first sibling? And they'd be like, 10. What's the age of your second sibling? And they'd be like, 14. What's the age of your third sibling? 18. Cool. And then at the end, I want you to print out the size of the vector and print out each of the elements in that vector. So there's your challenge problem, but there's more. If you want to have some extra practice, try writing a function that prints out the elements of a vector of doubles and use that in that practice problem. So basically you're taking that out of your main method, the looping over all the elements to print, and now you're making a print vector function. Also, try answering this question: why can't I use static arrays for this practice problem? Hint, go back to the example when we were first talking about the limitations of arrays. And then if you want some extra practice with vectors, after you print the variables, ask the user if they would like to remove a value. If they do, like maybe if they could type in y or n, the character y or n. If they type in y, then look through the vector for that value and remove the first instance of it. Then print out the rest of the vector. And if you want some extra practice, keep repeating that until the user says, no, I wouldn't like to remove any more elements from the vector. To do this, you're going to have to use that to look and see a little bit more of the features of the vector website, like how to remove an element. But that's your challenge, and it's a good one, and I would encourage you all to do it. So till then, till next time, take care, and Jess out.